Hello everyone. So today we are going to study about converse of Pythagoras theorem. It says that in a triangle, if square of one side, that is square of this side, is equals to the sum of the square of other two sides, that is sum of the squares of other two sides, then angle opposite to the first side, that means this side, first side, the angle which is opposite to first side is 90 degree. Okay. So we'll construct another triangle here. Let this be as P, Q, here we'll draw 90 degree and here R. So then let this BC equals to QR and AB equals to PQ. Okay. So now we have to prove that this is already given to us. Okay. They have said that hypotenuse square equals to sum of the squares of other two sides. Now we have to prove that this angle B is 90 degree. Earlier we were given this 90 degree in a triangle and we had to prove Pythagoras theorem. Okay. Now here we are doing other way around. Okay. So the step number 1 will take, here I'll write AB is equals to PQ. We'll consider this as given. Okay. Second step is BC is equals to QR. Right? So we'll write here construction, because we constructed this triangle, right? And here also same reason, this is BC is equals to QR by construction. Okay. And step number 3 will be, now so here we'll simply copy this paste, this statement, that is AC square equals to AB square plus BC square. Okay, this is given to us. Okay, so now first part is done. Okay, now all the written whatever is given to us, we wrote it here. Now we have to look at this triangle. Okay, we can now, since we have 90 degree here, so we can apply Pythagoras theorem. So step number 4, by Pythagoras theorem. So Pythagoras theorem says that high blood pressure, and square them all. So let this step number 4 be here. If you apply Pythagoras theorem in this triangle, you will get hypotenuse as PR square equals to base is QR square and perpendicular is PQ square. Okay. Now if you, this is by Pythagoras. Okay, there's no need to write down the reason, but still we'll write because some textbooks they have written this. Okay. Now if I observe this part, that is QR square, that is this part, QR is also equals to BC, right? That here, from here QR is also equals to BC. So I can replace, in place of QR I can write BC, and this square I'll put here as it is. So QR I wrote BC. Okay, plus PQ is here, this side is equals to this side, right? Here PQ equals to AB, so I'll write, in place of PQ I'll write AB square. Okay, I'll write the reason from step number 2 and 1, so 1 and 2. Okay, and this I'll copy as it is, PR square. Okay. Now if you observe this again, this side, this part I already have here. Okay, it was already given to us. Okay, so in place of this I can write AC square. So I'll just copy this part as it is, BC square plus AB square equals to, in place of this I'll write AC square. I can consider this, it's the same, one and the same thing. So AC square. Okay, we'll write here 5, 6. Now see, these two sides are equal. Okay, so that means this left hand side will be also equal, right? Step number 7. Therefore, PR square is also equals to AC square. If you remove the square, you will get simply PR equals to AC. Okay, now we have proved that PR, that is this side of my triangle, is equals to AC. So if this is 5 centimeter, this will be also 5 centimeter. Okay, now we prove that these two sides are equal. Okay, and this we had already taken as equal, right? So you can say that, okay, here we can write one reason from step number 5 and 6. Now step number 8 will be, okay, now we prove that these two triangles are congruent, right? So I'll take, in triangle ABC and triangle PQR, okay, my AB is equals to PQ. I'll write here AB equals to PQ, and BC is equals to QR, and this we proved, that is AC equals to PR. Now all these three sides are equal to this triangle. Okay, now so that therefore we can say that therefore triangle ABC is congruent to triangle PQR. Reasons should be by side test. Okay, so I'll repeat everything one more time. So this was given to us, we did this by construction, that is AB is equals to PQ and BC is equals to QR, and after applying, this was already given to us, so we just copy and pasted here. Now here in this triangle you have to apply Pythagoras. After applying Pythagoras theorem, I got this equation. After getting this equation, I did the replacement in these two parts, and now this I already had as AC square, so in place of this PR I wrote AC square. Okay, here you can say step number 5. Okay, we can say step number 3, sorry. Now here I proved that PR is equals to AC, that is this side is equals to this side. Okay, so now all of these three sides of this triangle are equal to each other, right? So I wrote this here, and then I proved that these two triangles are congruent to each other by side test. Okay, so just I'll get rid of this. Okay, now since the triangles are congruent, that means this angle A will be also equals to angle P. If this is 30, this also will be 30. In the same manner, this angle C will be also equals to angle R. If this is 60, then this also will be 60. And now here we already have that angle Q is equals to angle B. Okay, so right here, step number 9. Angle B is equals to angle Q by CP CT. Okay, that is corresponding parts of congruent triangles are equal. Okay, so I know here that so step number 10, but my angle Q is equals to 90 degree, which is already given to us, right? So now if angle Q is 90 degree, if I put this value in place of this Q, that means my angle B will also become, angle B will be also 90 degree. So that is what we had to prove. Okay, from step number 10. Okay, and you can write hence proved.